let's refresh our memory from our trig inverses notes day 1. And really, really important is the quadrants that we use when we're finding our answers to our trig inverses. When we're working with arc sine, we're in quadrants 1 and 4. And I won't even write them with Roman numerals. 1 and 4. The only answers for cosine are going to be in quadrants 1 and 2. And then tangent goes back to quadrants 1 and 4. The reason we pick those quadrants is so that we have a quadrant that has a positive value for sine, cosine, and tangent, which is always first quadrant, and then a negative value for sine, cosine, and tangent. And again, quadrant 4 for sine and tangent, and then cosine is going to be quadrant 2. What we also did in day 1 notes is we drew some pictures for our functions here. And our first function is our inverse sine function. So we picked points like -1 pi over 2 and 0, 0. You have them on your notes. And +1 pi over 2. And we do the picture. And that's our sine function, our inverse sine function. Our middle value there is the cosine function. And then the third one here to the far right is our tangent, our inverse tangent function. Notice the difference on tangent is that we have arrows on the ends here, and that our domain is all real numbers because of those arrows. So what we're going to do now is we're going to find the exact value of the inverse trigonometric functions. Remember the domain. So when we're answering questions for sine, we're either going to have positive values like positive pi over 3 or negative pi over 3. We're not going to have values 5 pi over 3 because of our domain in sine being restricted to negative pi over, our range in sine being restricted to negative pi over 2 to positive pi over 2. So when we look at these problems, what we're asking ourselves is, what angle of sine has a value of radical 3 over 2, and you may want to use your hands again to help you with that, but we're going to get pi over 3. What angle of sine has a value of negative the square root of 2 over 2? Well, that's going to be pi over 4, but because it's negative, we're going to be in the fourth quadrant, which is going to be negative. And then we get to tangent, our weakness. That's the one I think you should go back and study some more. But tangent of 0, at least we talked about it in our notes of day 1. What angle of tangent has a value of 0? It's still 0. Speaking of tangent, arc tangent, radical 3 over 3. What angle of tangent has a value of radical 3 over 3? Remember, 3 plus 3 is 6. And what angle of tangent has a value of 1? And what angle of cosine has a value of 1? It's actually 0. So when we get to number 7 here, what angle of cosine has a value of negative radical 2 over 2? This is the one that we need to think about a little bit more closely, because cosine's negative values are going to be in quadrant 2. So quadrant 2. And the thing is, well, what angle of cosine has a value of square root of 2 over 2? Well, that's pi over 4. But what's the value of pi over 4 in the second quadrant? And that's going to be the 3 pi over 4. Number 8, cosine, inverse cosine of 1/2. Well, what angle of cosine has a value of 1/2? Again, you may want to use your finger gestures, but it's going to be pi over 3. And then what angle of sine? So here's the arc sine, but it's still going the same way. What angle of sine has a value of 0? Still 0. Back to tangent here for a couple minutes. What angle of tangent has a value of negative radical 3 over 3? Well, luckily, if we look above there at number 4, we've got positive square root of 3 over 3, so it's going to be pi over 6, but tangent's going to be here in the quadrant 4, which means we're just going to have negative pi over 6. Inverse tangent of negative 1. Again, if we look up there at 5, we've got the inverse tangent of 1 is pi over 4. So if it's negative 1, it's going to be negative pi over 4. And once again, looking back at 8 here for the inverse cosine. What angle of cosine has a value of negative 1/2? Well, it's going to be a pi over 3 radian, but we need to know what's the pi over 3 value in quadrant 2, and that's going to be 2 pi over 3. So cosine is the one that's a little bit odd, if anything is. As we turn our paper over and just do a few more practice here. The inverse sine of negative radical 3 over 2. The bad news is we can't see that one, but it was the first one that we started on our examples. And if we look back at problem number 1, we see that it's going to be a pi over 3 value, except that now we're going to be in quadrant 4 because it's negative. So this is negative pi over 3. The inverse tangent of the square root of 3 for problem number 14. Well, what angle of tangent has value of radical 3? It's just going to be pi over 3. Number 15. What angle of sine has a value of negative 1? Those are the quadrantals, and you may need to go back and remember that. But if you think about this value here, this value is 0, negative 1, and we need a y value. So where is that? That's at negative pi over 2. Notice, we're not saying 3 pi over 2. And that's going back to the value of the range here. Where are we looking? Number 16, cosine. The square root of 2 over 2. Again, maybe you need your fingers to help you remember, but this is going to be pi over 2. Number 17. What angle of tangent has a value of square root of 3 over 3? I think this is even a repeat, because 3 over 3 is going to be our pi over 6. I'm pretty sure that's a repeat. Let's go back to 16. I don't know what I was thinking. What angle of cosine has a value of the square root of 2 over 2? Should be pi over 4. I just got caught up with all those 2's, I think. I don't know. But thank you for correcting me. Inverse tangent of 1. Again, I'm starting to feel like these are repeats. But maybe we'll really know them if they are repeats. but this one should also be pi over 4. And almost done here with these, so we can challenge ourselves a slight bit here, hopefully. With arc sine of the square root of 2 over 2, what angle of sine has a value of square root of 2 over 2? Still pi over 4. What angle of tangent has a value of negative square root of 3? Well, if we can see problem 14 up there, we know it's going to be a pi over 3, but because the angle is negative, we're going to be working in quadrant 4, so this is going to be negative pi over 3. And then the arc cosine of negative the square root of 3 over 2. Well, that's going to be a pi over 6. But because this is negative, we're going to be in quadrant 2. So what's the pi over 6 in quadrant 2? It'll be 5. So lastly here, it didn't look like that was too much of a challenge, thankfully. But we do need to make sure that we are familiar with our unit circle. So you may need to go back and look at your unit circle again. But as we finish here, we're going to do some composite functions. So composite, sorry, we got interrupted in this, but composite functions. We're going to be dealing with more than one function is what we're dealing with. And when we deal with composite functions, we need to start on the inside. So what I wrote on my paper is I wrote start here. Start here. So we want to figure out what's the inverse sine of square root of 2 over 2. In other words, what angle of sine has a value of square root of 2 over 2? Well, we know that that value is pi over 4. So we've figured out what that is. And now to finish this, we're going to say, well, what is the cosine of pi over 4? We don't have any restriction on this answer. The cosine of pi over 4 is square root of 2 over 2. When we go to problem 23, arc cosine of negative the square root of 3 over 2. Well, if we look back at problem 21, we know what that value is. We just did that problem. But we're going to start on the inside, starting far right here in this problem. And as we look up at 21, we see that the answer here is 5 pi over 6. We have a restriction on that. But now we don't have a restriction on tangent of 5 pi over 6. And we need to really think about what this answer here is. But it is a pi over 6, which means that it's going to be square root of 3 over 3. But 5 pi over 6 is in quadrant 2, and tangent in quadrant 2 is negative. So lastly, for our final challenge here, we've got secant of the inverse tangent. But when we start on this particular problem, we need to start far right, start at that parentheses, the inverse tangent of the square root of 3. Again, if we look back up there at 14, we see that the inverse tangent of square root of 3 is pi over 3. But to finish this, what we need to do now is we need to figure out, well, what's the cosine of pi over 3? Sorry. We need to figure out what the secant is. And I'm ahead of myself because secant has a reciprocal of cosine. So I do want to look at the cosine of pi over 3. And we know that the cosine of pi over 3 is 1/2. Well, secant and cosine are reciprocals. So to finish this problem here, we just want the reciprocal of 1/2. which is 2. I'm going to circle that one so you can see what our answer is.